Hello, everyone. Today we're going to go through the last part of 205, which is the real world scenarios. So, our goal for today is that when we're given some sort of real world situation, a lot of times, you've probably heard this called a word problem, that we will be able to write an equation and then solve that equation in order to, find our answer and solve that real world scenario. Something that I like to do whenever I get to word problems is I like to read it 3 times. The reason for that is whenever whether it's a word problem or just a, regular problem, but the directions are a little lengthy, the reason I read it 3 times is the first time is just a quick read through to kind of get the gist, get a little overview. And then the second time is when I'm hunting for that key information and then looking to see what's exactly is my question? What am I trying to find? And then when I'm all done solving the problem, I will read it a third time just to make sure that I didn't miss anything, mess anything up, make sure that I truly answered the question that was being asked of me. So if we have this problem here and I read it for the first time, it says you bought a magazine for $3 and some candy bars for $2 each. You spent a total of $19. How many candy bars did you buy? You could and there's nothing wrong with this strategy, but you could solve this problem by doing what I call the guess and check method, where you could kind of look at your information and like tally things up, do the math off to the side, and use that to answer the question to figure out how many candy bars it bought. That's a good strategy. What I'm going to do throughout our entire lesson today, and my goal in teaching you, is how to write an equation first and then use that equation to solve. The two benefits for that, one is, surface level benefit, because sometimes tests will ask you simply just to write the equation. So surface level, to get you to understand how to write an equation, because maybe that's all you needed to do. But on a deeper level, the reason for that is it can really help later on in the future in math, and even potentially in your real life, you solve something. For example, the other day, when my husband was working, because he works from home as well, I overheard him, and he was having to come up with an equation because they were trying to figure out, all right, how many hours does it take to do this, this, and this? So they could figure out, do we have enough people that are able to get this job done? Or do we maybe need to look into hiring a couple more? And those equations with those variables let you say, okay, it lets you play around with different scenarios and run different situations to see what you need. So that's more of a long-term benefit to the knowledge of how you can write an equation to help you with something. All right, let me hop off my soapbox here and let's get back to the actual problem. So we read it once. You may need to read it again. You've maybe forgotten since I got off on a tangent there. But as we read it a second time, we're going to go through and, underline, circle, highlight, whatever you want to do. In your case, it may just be jotting it down on a piece of paper, those key pieces of information. So you bought a magazine for $3. Okay, so the magazine was $3. And it just says a magazine. Okay, so that means if you bought a magazine for $3, I bought one of them. And then it says some candy bars for $2 each. So I don't quite know how many candy bars, because just some. And then it says I have a total of $19. And then my overall question is, how many candy bars did you buy? Well, hey, that kind of works with what I already identified was, I don't know how many candy bars, because that's what we're trying to find. So these 3 steps on the board here are going to help you, and these are generic steps that work all the time, to write an equation. So first off, you need to identify your variable. Your variable, remember, is an unknown value. So it's what you're trying to find. And what we're trying to find is how many candy bars we bought. So I'm going to use the letter C to represent the number of candy bars. And I like when we have word problems to use variables other than X, because then as I'm solving, it helps me remember, well, C stands for candy bar. Now we need to write the equation. So we're going to take all the information that we were given and write that as an equation. Well, we know we bought a magazine for $3. So $3 was spent. And I bought some amount of candy bars for 2 each. So if I'm also buying that, it's going to be addition because both things are being purchased. And I know the candy bars cost $2 each, but I don't know how many I bought. So that'll be 2C to represent it's $2 for every candy bar. And then I spent a total of $19. Well, if that's my total, that is what we are equal to. Now that the equation has been written, we can come over and solve that equation and find out how many candy bars were purchased. I'm going to rewrite it up here in order to help me solve. So if we want to get C by itself, we'll subtract 3 from both sides, and we're left with 2C equals what? 16. Divide by 2, and C equals 8. When you do get to real world scenarios, you don't really want to leave your answer like this. You need to, put a label with your answer. And that's where it's helpful, like, because I know, hey, C is the variable I picked. C stands for candy bars. So it makes it easy to remember. My answer is I bought 8 candy bars. All right, I believe I'm done, but I'm going to go back for one final read through to make sure I actually answered what it was asking of me. You bought a magazine for $3 and some candy bars for $2 each. You spent a total of 19. That matches my equation here. So that was correct. And then I wanted to know how many candy bars we bought. 8 candy bars. How could you double check your answer if you were feeling a little nervous, you were, not wanting to move on to the next question or hit submit? How could you go back and double check your work? Hopefully you said plug it in or substitute it. So you could put that 8 into your problem. Say, all right, I bought 8 candy bars for $2 each. That's 16 bucks plus a magazine, 16 plus 3 gives me a total of 19. It all checks out. Okay, let's try this problem. Hunter's graduation picnic costs $6 for every attendee. At most, how many attendees can be there if Hunter budgets a total of $42 for his graduation picnic? All right, so now let's read it again, see if we can find that important information. So it costs $6 for every attendee, every person. And it says at most, how many attendees can be there if Hunter budgets a total of $42? And then our question, because that's a really long sentence for a question, so let me read that again. At most, how many attendees can be there? All right, that's the question. We want to know how many attendees, or to make it easier, how many people can be there. So step 1, now that we've identified our information, is to pick our variable. Well, our variable is how many, we're trying to find how many people that can attend. Therefore, that's our unknown amount, meaning that's our variable. So we can use A for the number of attendees. And then now we need to write our equation. So when I read through this, it doesn't look like there's any startup cost. Like, on the last one, there was, $3 for the magazine plus this other amount for the candy bars. In this case, I'm not seeing any other cost for this graduation picnic other than the cost for the attendee. So it's going to cost $6 for every person that shows up. So that's 6A. So it's $6 for every person that shows up. And then he's budgeting a total of $42. Well, if that's our total, it's going to be equal to 42. There we have our equation. Now we can solve. I'll change my color here for the solving. This is just a one-step equation. Cool. We'll divide both sides by 6. 6 divided by 6 is 1. A is equal to whatever 42 divided by 6 is. What do you guys get for that? 7. But remember, since this is a word problem, we don't just want to leave our answer as A equals 7. We want to really answer the question, put a label with it. So it's 7 what? Well, A is equal to number of attendees. So that means there can be 7 people that attend on his or with him for this picnic. So if I read it one final time to make sure I'm good, I'm going to focus on the question here. At most, how many attendees can there be? Well, that's what we just found out. There can be 7 attendees. If I wanted to double check, I could substitute it in. 7 people show up, $6 each. 7 times 6 is 42. All right, let's check this one out. Mrs. Ailstock went to the movies and paid $2.80 for a snack using only quarters and dimes. She used 6 quarters. How many dimes did Mrs. Ailstock use? Well, first off, that's kind of mean of me to do that to the employee, give them all coins. But you know, sometimes you got to do what you got to do. If that's what you have on hand, that's what you have on hand. But all right, so let's reread this and see what we're all dealing with. So I went to the movies and I paid $2.80 for a snack. And I only used quarters and dimes. I used 6 quarters. And then we want to know how many dimes did I use? Okay. So first off, we need to pick our variable. Well, the thing that is unknown is how many dimes that I used. So therefore, we can just use the variable D to represent the number of dimes that I paid with. All right, so if I paid $2.80 for a snack, that means that's going to be my total. So sometimes you can work a little backwards. Notice that I'm kind of setting these up a little bit differently, trying to show you some different thought processes here. So I know that my total is $2.80 because that's how much I paid. And then I used 6 quarters. So would I just put a 6 down? I need to do a little bit more than that because it's not that I had $6 or 6 cents, it's that I used 6 quarters. And my total over here is in dollar amounts. So therefore, when I'm setting up my equation, I need to make sure I'm being consistent with dollar amounts because I need, or maybe I should just say money amounts because we're kind of working with cents here. So I need money amounts to equal money amounts. Now, how much is a quarter worth? Well, a quarter is worth 25 cents. So if I have 6 quarters, I could multiply that by 25 cents, and that will tell me how much of that was paid for in quarters. And then I also use dimes. So if I also use dimes, both of them were used together, that's going to be addition. And I know D is representing dimes, but would I just put a D there? Or do I need something else? I need something else. Just like with the quarters, I have to put that money amount. So it's 6 quarters times 25 cents each, plus however much a dime is worth times the number of dimes. Well, a dime is worth 10 cents, so we can express that here. So sometimes you'll get problems that require you to use some background information. They didn't straight up tell you how much a quarter and dime was worth. They were like, all right, you're in 7th grade. You should know that. But the application of it is where it can get tricky. So this is a really good one for us to do together. So just for a quick recap here, let's look at our equation, make sure we're set. And it looks like we are. We have 6 quarters, and I'm multiplying that by the amount, the cost of a quarter, 25 cents. And I use dimes, so we're adding. I don't know how many dimes, so that's my variable D, but I do know it's worth 10 cents each, so I can multiply that. And it is equal to the $2.80 I paid for that snack. All right, let's solve our equation. Well, first off, whenever we have an equation that needs simplified, we have to simplify before we can solve. And right here, we can simplify by figuring out what 6 times 25 cents is. And that is $1.50 plus 10 cents per dime equals $2.80. All right, now that we've simplified, we can go about solving. So we're going to subtract $1.50 from both sides. We're left with 10 cents per dime is equal to what? $1.30. And then now if I divide both sides by that 10 cents, what do I get? I get 13. So D is equal to 13. All right, now here's where our label comes into play. It's 13 what? $13? 13 dimes? That D, if we look back up, stands for the number of dimes. So 13 dimes and 6 quarters is how I paid for that snack. If I look back up at my question, that matches. I wanted to know how many dimes. Looky there, that's what I figured out. All right, guys, we'll do a couple more examples together. So those were some examples where we had to literally do everything. We had to write the equation and we had to solve it. I want to do a few examples straight from your IXL skill. Now, this IXL skill is HCP, solving 1- and 2-step equation word problems. So we'll just do a couple of these and then we'll close out the video lesson so you guys can get on to your next math task that you need to accomplish. So the Sea and Sun souvenir shop is known for its specialty saltwater taffy. Every week, Dylan fills a gigantic jar with taffy to put in the storefront display. This week, he puts 500 pieces of cherry taffy, but still has more space to fill. Dylan fills the rest of the jar with banana taffy, his favorite flavor. In all, Dylan puts 725 pieces of taffy in the jar. Which equation can you use to find how many pieces of banana taffy B are in the jar? Whew, this is definitely one that requires more than one read because that was a lot of information. All right, so the gist of it that I got from that is we have this guy Dylan. He's filling a jar with some taffy, and we're gonna write an equation from that. That's what I got from it. So let's read it again and really hunt for that key information. All right, so the Sea and Sun souvenir shop is known for its specialty saltwater taffy. Every week, Dylan fills a gigantic jar with taffy to put in the storefront display. So this week, he put 500 pieces of cherry taffy, but still has more space to fill. He fills the rest of the jar with banana taffy, his favorite flavor. In all, Dylan puts, so in all, that means total, He put 725 pieces of taffy in the jar. And then our question is, which equation can you use to find how many pieces of banana taffy B are in the jar? So in this case, they've already identified the variable for you. That's what they did right here. They're saying, all right, banana taffy, we're using the variable B. So I'm gonna honestly, like, I'm not good with multiple choice. Sometimes that makes me, pick the wrong answer because I'm like, oh, that looks right, but it's really not. So I personally like to try to figure it out on my own first and then see if what I got matches the multiple choice, but that's just me. So if I look at my underlined information, so he put 500 pieces of cherry taffy in there and he put some banana taffy, but we don't know how many. So that would be our variable B. So there's 500 cherry pieces plus some number of banana pieces, and that equals in all 725 pieces. So is that an answer choice we have here? Oh, look, it is. The only difference is they put their variable first, but because it still matches with your positive signs, it's the correct choice. B plus 500 is the same as 500 plus B. It's that commutative property where 2 plus 3 equals 5, but 3 plus 2 also equals 5. You can switch them around and it's still the same answer. All right, that's the first half of what this IXL wants me to do. The second half, read down below, is we want to solve this equation for B to find how many pieces are in the jar. So if we want to solve for B, we need to subtract 500 from both sides. So B is equal to 225 pieces of banana taffy. All right. All right, this will be the last one we do together. As you get a little higher in the IXL, it's going to stop writing the equation for you. So the beginnings to kind of help get you warmed up, it's giving you that multiple choice, kind of helping jog your brain with the equation. But then as you get higher in the SMART score, you have to write it yourself first. So this will be the final example we do together. Jacob and his parents are going to visit Mitford University, which is 455 miles from where they live. They plan to drive for 4 hours on the first day, then stop at a hotel for the night, and complete the trip on their second day. They expect their average speed will be 65 miles per hour. How many hours will they drive on the second day? Write your answer as either a whole number or a decimal. All right, so I know we're doing something with driving and we're staying overnight somewhere. Let's read it again and see what we got information-wise. All right, so they're going to Mitford University, which is 455 miles from where they live. They plan to drive 4 hours the first day and then stop at a hotel for the night and complete the trip on the second day. They expect their average speed will be 65 miles per hour. How many hours, so that's our question. So how many hours will they drive on the second day? This is a good one. All right, well, we got to pick our variable this time. So we want to know how many hours they will drive. So let's use H for hours. And it says that this university is 455 miles away. Well, that's how far we're driving. That's going to be our total. And then they drive 4 hours the first day and complete the rest of the trip the second day. So would it just be 4 plus H? Would that be correct? Well, let's look at our labels here, because what's the 4 represent? That represents 4 hours, right? And then the H also represents hours. Is this 455 hours? No, that 455 is miles. That means we're missing something here because we can't have hours plus hours equal miles. That those labels don't match up. That means I got to have some extra information in here. Ah, looky here. Here it is. They're giving us the average speed. Obviously, this is just, you can run into traffic, but they're saying, all right, our average speed here, we're going to be on lots of highways, is going to be 65 miles per hour. That's what we need. So that means every hour they'll be going 65 miles. So let's do a little erasing here so we can fix this. All right, if they go 4 hours on the first day and they're traveling 65 miles per hour, that's going to be our first piece of information here. So 4 hours are driven at a speed of 65 miles per hour. That gets the miles in there to equal our total. And then the second day, we don't know how many hours, but they're going to be driving at the same speed. So 65 miles per hour times h times an unknown number of hours. And that's going to equal 455 miles. Now our equation's good. So let's first start off with simplifying that. We need to multiply 4 times 65, which is 260. So they'll have gone 260 miles that first day before they stop at a hotel. And then to solve for h, we need to subtract that mileage. So 65h equals 195 miles to go. So then on that second day, we'll divide by h here. And what do we get? We get the answer of 3. So that means on that second day, they are going to have to drive 3 hours. And looky there, the label's already there for me. And if I look back at my question, it wanted to know how many hours. H equals hours. 3 is perfect. All right, now it's your guys' turn to work on assignments. So first off, make sure that your graded IXL this week, which is XDE, is done. That's what we had yesterday on Tuesday, the 25th, going over types of solutions, whether it had one, infinitely many, or no solutions. Now your unit test is open. This was our final week. So you have a 205 unit test open. You can go ahead and work on that. And then if you would like to do this extra credit assignment, HCP, that matches today's lesson of working with word problems and writing those equations and solving them, you can complete that extra credit assignment if you choose to do so. But the 2 underlined here in blue, those are the official requirements that if you don't do, you would get a missing 0 for. All right, guys, if you have any questions, as always, email me or you can come to a help session, but if you don't want to wait until our next one, email will get you some assistance a little bit sooner. All right, guys, I hope you have a good rest of your day. Rock out this unit test, and I'll see you later. Bye.